provide edge computing solutions that are designed to stay running under any circumstance and be maintained by anyone at the site. So with that said, I would like to Eric.
Thank you all.
All right.
Last one to present. I'm sure everyone's eager to move on with the day, but I will do my best to try and find the content. So first of all, again, Zach did a great job. I found this class
Wow.
that I received. It says 2006. Is it possible that's wrong?
Yeah, that is.
So I was a member of this organization for a while back then, and then due to life and job changes, and so I rejoined a few years ago. I wanted to give you a little framework of where I'm coming from. So I'm not a direct practitioner in charge of continuity company, a vendor in that space. The reason I joined then, the reason I joined again years ago, is to learn, quite frankly, well, to understand how you view the world and what's going on in direct end use organizations around continent. So again, I'm mostly here to learn, but I thought I'd impart a little bit of knowledge, hopefully, in regards to technical compute. I've had a chance to sit in on some of the fireside chats. It's already been educational. And I'll try and give back to the organization as much as I can, although, as I said, I think I'm going to do the learning at that, but I do my best to try and participate. So I thought I'd at least set the framework to let you know. And more perspectives. You guys view the world, as I'm learning, from the listing entire organization how to running, right? I'm going to deal with specific compute environments today. So it may not resonate necessarily in terms of the entire enterprise, the way you guys view the world, but again, I just want to frame where we're talking. Some of the vertical markets that I work in that again help you understand where I'm coming from is I work in quite a bit in industrial automation and manufacturing. So work with folks on the production line, talk about the cement portion of the business, not the carpeted portion, where the executives and so on. So we're dealing in my everyday world. I'm dealing with controls engineers who are great about getting something out of the other end of the factory and not necessarily the folks maintaining the email servers, the corporate backend. Retail is another environment. My company talks about edge computing. So we're dealing very often with folks that aren't, again, operating out of that main data center environment. I am going to talk a little bit about data center solutions here as well. But again, we think very often from edge use cases. So pumping stations on an oil pipeline, for instance, production floor on a plant, things of that nature. So that's kind of where I see the world. Did a little research here. This was a nice exercise for me because I know my stuff really well inside and out. I started with the current company in 2013, so I certainly am more of a technical sales guy, not an engineer. Know our stuff real well. I know what we encounter in the field, which is what I'm going to talk about. But I also try to do research to be part of it. This is all the stuff I'm guessing everybody in this room knows inside and out, right? Recovery points, recovery time, backup, etc. My assumption is this is bread and butter for what y'all are doing every day. And so that's disaster recovery. What I'm coming at and what we talk about and hinted at, explicitly mentioned actually in my bio, is DA or disaster avoidance. So what we're trying to do in a high availability or fault tolerant computing environment is set up a computing environment that is built to withstand things that are going to happen within that compute environment to keep software applications up and running. Again, not the holistic, how do you keep the company up in a hurricane, but how do you keep your software applications running on an environment of compute, various compute options. That's what we're going to talk about. So the goal is right side of the screen. You want the brick digging house that can withstand the challenges that it faces rather than an environment that down and cause downtime. terms high availability and fault tolerance interchangeably when they're talking about computers. And we think there's a pretty important distinction. So when we talk about high availability, we're talking about a pre-set up that, again, we'll show you here several examples, so that if a part of the compute stack fails, there's a structured recovery in place. So it's already set up. There's various clustering technologies and things that I'll talk about that are set up so that the software will go down for a period of time, but it'll automatically restart without any manual interventions. Nobody needs to get in the truck or hit the data center or go do anything to the computers. It is all set up to structurally recover. But there is downtime. So again, if I go back to manufacturing world where I spent a lot of time, they use something called HMI screen, human machine interface, so that they can interact with the production line. And so if they have an HMI application that's running on a system in a high availability setup, and there's a problem with that computer, the screen goes away for a little while, blue screen of death. Some of you are going to young to know what that is. Some folks probably remember the blue screen of death. We don't get this. But then there's a structured recovery. Fault tolerant computing is the next level. So this is designed to create a computing environment. So regardless of what happens to that computer underneath covers, software keeps running. So there is no blue screen of death. There is no restart. The software is automatically running. Yes.
Do you consider this the differentiation at the actual app layer, or is this with the user and the transfer?
I would say both. Yeah. The idea is to keep the software applications running. So again, I go back to the world I live in all the time. I brought up HMI. That's the screen that the operator is using to make sure that the machines are spitting out the moving things along the production line. They also do things called historian, which is basically a database of storing all the activities. We work in a lot of regulated industries where there's FDA and they can't have any errors in their data. So beverage, water, wastewater, things of that nature. If their historian data is corrupted in any way, shape, or they can face have problems with public. So it could be the interface layer. The idea is any applications that you're running on this. All right, so the two most common things that at least we see in the field are what's known as a cluster environment. And VMware is the market leader in that space. Microsoft also has their own solution. They work very similar. As far as where we talk about edge versus cloud, you can put these anywhere. So they're very often going to sit in a data center environment because this is something that your IT teams are working with constantly. They're maintaining them, they're keeping them up to date, they're very hands-on, and administrative, and maintenance required to keep these things up and running. And so the key is, I think, some other presentations I'll talk about in different ways, is testing, making sure that things are up to speed. Again, it's very hands-on. They are the standard IT approach to handling high availability type solutions. And the cost can add up because there's a lot of these. So this is kind of a image of what VMware, how they dictate what's the best practice. So again, they're pretty ubiquitous. So the various components here is you have an external storage device where you're storing your data, very high speed switches. VMware would tell you need at least 3 nodes and 3 servers that are part of your cluster. A lot of those 2 in, but VMware would dictate the best practices. You're going to have, again, VMware licenses and multiple Microsoft licenses. And the way that this cluster works is that you are running your workloads on one, you've got applications running on one of the computers in the node, one of the nodes. And in the event that, but the data is all getting pushed and stored here in this area. The idea here is if I lose this computer, these applications are going to get restarted somewhere over on the other computers. So if the data is stored locally here, you can access it. So again, the idea here, VMware, it's their Essentials Plus licenses. They have something called HA, which and they have something called vMotion, which is what the IT guys use to manually move data around and manipulate the cluster. So vMotion is an important part of this, again, because this is something that is going to be monitored and maintained. So what happens here? Let's say this guy dies, his applications go away, and extreme death for a while, but they're set up to automatically recover these other boxes. Microsoft with their Hyper-V, essentially the same way. A lot of the other vendors in this space now, there's something called hyper-converged computing that you're probably familiar with or have heard of. Nutanix is kind of the industry leader from that perspective. Dell and HP and everybody has their own versions of that. And it's, although those vendors might collapse all this into a multiple rack, multiple configuration in a single rack, essentially what they're doing is the same thing. They're basically taking the applications and replicating them across multiple computers and striping them in various fashions. And this is a very common scenario for a high availability cluster. And then I talked about fault tolerance. VMware also offers essentially the same thing with fault tolerance. However, my personal experience, having been doing this for 10 years in this current position, very, very few organizations have the team version of this cluster. It's extremely processor intensive, extremely compute intensive, and there's most companies, most of their applications live at some level of restart and downtime. Whatever the case may be, you can live with a little bit of downtime of the applications. It's a little frustration for users, but as long as it's not critical data, HA, high availability. And so, as far as cloud-based, there's a lot of options out there. And again, researching this presentation, I certainly am sure you're going to be thinking to themselves, I know of this vendor that he's not mentioned. There's no way I can stand up here and describe all the various vendors. So I'm trying to give a framework on the overall solution. So, old school for cloud-based is you take your equipment and co-locate it somewhere else, right? That's essentially. You put it in a data center, you can manage it yourself. You can run a data center. I think Ed earlier described all that the solution stack in terms of various iterations, whether it's just an application, it's infrastructure as a service, and that all falls within this. That I didn't go into that pretty early. And then the new school, you've got a lot of Alco, Amazon, Azure, of course. And then there's a lot, all sorts of regional vendors. That's again in my biography. That was where I got started back. One of the first companies to do infrastructure as a service, actually, based on Grand Rapids. The Signal, so sold all kinds of that. There's all sorts of iterations that I'm sure your organizations today. But underneath the covers, back at the data center or in the cloud environment, they're doing something similar to what I just showed you with that cluster environment. Obviously, at scale, much different technologies than what I showed you there, but very similar process. They're basically running applications, replicating them very quickly, nice switches, fabric, etc., and making them available. That's essentially. When you're looking at cloud, and again, I'm preaching to the player here, I think it's some of this, but obviously you need multiple paths. Relying on connectivity that is not inside your building, better make sure that backhoe doesn't take you out when you're doing construction. As I mentioned several times, very administrative and it's intensive, but if you're supporting multiple sites, again, obviously, it's the way to go. And again, is that lots of favors. So, fault tolerance. Remember, I said disaster avoidance, zero downtime. There's different vendors, and I'm a little bit familiar with some of them. So, this is where Zach will appreciate this. I did a Google search, which, of course, there was 16 advertisements. Then you can kind of work your way through. So as far as use cases for ChatGPT, just as a search engine, I think it's a great way to narrow that. So what I did, fact check the data. That's what I'm saying, it's a search engine. I'm not saying, just saying that it's a post on the document. So this is exactly what I did. And Zach, we didn't rehearse any of this, right? This was the prompt. And so I specified what to act as an expert in information technology. Selected it. Basically, and then I included from the research I've done on YouTube. It's very important to find something like do not deviate away from my discussion. This repeats in a little bit of the box. So as we also saw with Zach's presentation, chatting very friendly. So it says start with certainly, and then try to, and I compress it. It's just. So I asked them to identify 3 leading fault-tolerant computing solution vendors, and just so you know that I didn't just come up here to do, a commercial for my company. We were listed, so this is, if you're wondering why I'm describing our stuff, we are part of this. So, is anybody familiar with some of these? The HPE solution, Integrity Superdome, or the Oracle solution? Because this was really interesting for me to dig into. And I don't want to go too, and this is going to get technical a little bit here, and the point here isn't to make anybody into an IT expert, I don't think, but at least provide a little bit how they're doing it. So HP, and they, incidentally, you may have heard of, they absorbed many years ago a company called Tandem Computing that a lot of folks are familiar with. They were on Stratus, they were the 2 main vendors in digital equipment. There's 3 main vendors in fault tolerant computing space going back to the 80s. Tandem was the one that I think was very well known. And so HP absorbed them several years ago and kind of took their technology and baked it into some of their products. That's the genesis of this. So they define their RAS architecture, which stands for reliability, availability, and serviceability. They describe it as fault tolerance, and ChatGPT thought it was fault tolerant. As I dug through the actual documentation, they do kind of talk about recovery from failure and not sort of fighting through it all the way. So they might be using a slightly different definition than the way I described it. But again, this is straight out of their documentation. So their fault management, again, sort of implies again that you're you see the various steps here: detect and contain for data integrity, log, analyze, and repair. And this is the 4-stage strategy that's the overall architecture for how they're doing it. Basically, as I dug into the documentation more, they do describe very specialized firmware first fault management. So they are using very specialized components that is not necessarily off the shelf Intel processors and things of that nature. They are designing and engineering some of their own pieces, parts, and components that go underneath the covers. And so it is a bottom-up approach. It isn't just taking an existing system like the cluster environment that I showed. This is stuff that they call it RASified for all the various pieces and parts. And I suspect that most folks in here are familiar with the various RAID levels for taking hard drive data and striping it across multiple, or taking data and striping it across multiple hard drives. They make available all the various RAID options. And a lot of vendors, when you dig into their documentation, that is their solution for the availability, is simply incorporating some sort of RAID for the data. That certainly doesn't protect your processing. It's not memory level. That's just taken care of. And again, this looks like a very valid solution. I haven't come across it in a while. It's based on just research last month. But it does look like they've got a lot of use cases, a lot of customer friendliness. And it seems like it's quite good, doing well in the market. Another one that came up in the research is from Oracle, and this is basically a database. So similar to what we're talking about with the RAID, it is really pretty focused on data straight across. In this case, memory. So they're doing in-memory fault tolerance. And again, not to get too too deep into the technology, but they use both the way they access the data is quite a bit different than how other vendors are doing it in terms of being stored in memory with both a row and column format. And that's very much in the weeds. But what that does is it basically achieves a very effective way to keep the database up and running. Super expensive, as anything with the word Oracle in it is going to be a reason. But it is a very effective, it seems to be, again, a very effective way. This is something that is even next level beyond the complexity that I was describing earlier. This is like, it's got its own programming language to it. It's essentially, you are going to become an expert in this technology to utilize this version of fault tolerance.
Different between the two units.
I'm not an expert in either of these, but this one I think is very database specific versus the other one, where if you're looking at the more holistic workloads, kind of like your previous question. I think the HP version is going to take care of all your processing and your backend data. This one seems to be a little. And then the last one, as I mentioned, the last vendor is the one that I know really well. So I won't give you the commercial, but I'll at least explain what we're doing. So we have a single box, basically. So it's almost like a cluster inside a single server. The way we do it is through a proprietary process, lockstep. There's two halves to this system. So the top and the bottom half each have all the parts you find inside of a normal computer. And what we do is we lockstep the CPU at the top and the bottom. So you're running a single software image simultaneously in both places. So with our system, you can literally pull out half the system and the software keeps running on the other half of the system. So there is no that data replication that we talked about with high availability type solutions and some others. There is no replication because it's a single, the same software is running simultaneously on the top and bottom. So that's our approach. So it's a little easier. Our value prop is that it can be maintained by hands. Once the thing's up and running, any replacements that need to be done to our system is hot plug. It's not just hot plug hard drives, it's the entire system. I mentioned I do a lot of industrial automation, where it's a controls engineer who is managing the system. It's not IT basic. So again, we've been around. I trust you've heard of the Oracle. And I'm guessing you probably have stress. I always say our marketing folks, lots of marketing, but it's very stealthy. It's spread out there, but nobody can actually see. But in certain environments. And again, that was the high level overview. We skip that because that's commercial, but that was what I had. Any other questions or?
You'll be surprised. We used to have Stratus machines in our data.
Oh, is that right? Right. Like I said, the company's been around for a long time. LK's been around since 1980. Girls do out on the street. Like I said, we're very focused. Profit in specific vertical markets rather than IT. And like I said up front, the main thing for me is trying to get to know y'all here. What's going on in your guys' worlds. Hopefully this had a little value, a little bit more technical, perhaps. Just give you an introduction into high availability fault tolerance.
It's very, very enlightening. Here.